Now I'm recording, so I will only behave maturely. Oh my gosh, that's bright. Is that too? That's too. Is this better?
Yeah. Yes.
Oh, another one that'll cause you some medical issues. Medical health issues. Today is the 22nd. Today is 2/2/2/2/4. Interesting. Today we will start, not complete, but we will start the process of solving log equations. This assignment, when you get it, I don't think it says it on it. I might have named it this way on my hard drive, but I think I called this equation like solving simple log equations. So I think if you understand how to do the water cycle and you know how to solve quadratics and stuff like that, like I don't think it ever really gets super hard. I think that they'll get harder, but today's is pretty much just sort of our introductory course in mechanically how to go about solving an equation that has logarithms in it. So I say they'll get worse once we start learning how to expand and condense logarithms, and then yeah, that's that. So anyways, we won't worry about that today. So I have 9 examples in order. So I almost forgot to do a basic one, so then I had to draw a little arrow on my note card. But here is our first example, super easy. Like bottom of the barrel kind of thing. So as soon as you see a logarithm in this format, then you know that we're within our rights to hit it with the water cycle, right? And if we do that, just always remember that you want to start from the base of the log. So down here, so we're going to say 9⁻³ equals x. This is a self-solving equation. This is one of those times in math where you create an equation and you're like, oh my gosh, like it's already done. So does anyone know what 9⁻³ power is? It is certainly not 27. You would be off by 702 if you said that. It is 729. Very good. So x, when I write this out, it's going to say, let me not skip any steps like this early in the lesson. That would be a bad move. So it's going to say 9⁻³ equals x. So that's just the construction process. When we convert it over from logarithmic to exponential, hit it with the water cycle, and then 9⁻³ is 729. So we would just make our claim in an equation like this that the answer is proof 729. There's going to come a point in time, not today. So again, I'm only going to just mention this and sort of breeze past it, where we're going to start getting extraneous solutions. You'll remember those from the past where I think we got them with absolute value equations where we would solve them, I think. And then we would get like maybe sometimes 2 answers and one of them wouldn't work. Do you remember how there would be like a negative in the absolute value or something like that? So that's not going to happen to you with this format of log equations. Just know also, again, foreshadowing here. I don't know if you can call it foreshadowing when you just tell someone, but that's coming, okay? But today we don't have to worry about checking our answers. We're not going to get any weird stuff today. So these do not lend themselves to that. Any questions just on that basic process? All right. So from here, they'll get slightly more complex, but really just, again, it should be a pretty chill thing here today. So our second one, we're going to do log base 8 of 2k equals 2. So I'm trying to scaffold these upwards so that by the time we get to the ones that take more than, 2, 3, 4 steps, we don't feel the burn. It's like easy peasy. So hit it with the water cycle, and that means that this to the power of this equals this. What's that going to say? Right. So 8 to the power of 2, which this time I am just going to go ahead and evaluate that because I feel like probably don't need to show that. So 8 to the second power is 64. So I can just write 64 equals 2k. And it happens very quickly that it literally morphs from an 11th grade math problem into a 6th grade math problem just in the blink of an eye. And then we divide both sides by 2, of course. And what is k? Done. 32. Okay.
How about 2 2?
Ah, yeah, I never really thought of that. I wrote this, I was never even crossed my mind. How about this one? Why is this little, let me see if I can get rid of this little hide thumbnail video. Why is it still there if it says? I'm sorry, but I don't think that's ever been there. You do? Man, I should have known coming from that desk that that was not going to be a serious comment. Log base 6 of the quantity m plus 6. Did you finish that? Thank you, Morgan. Good day. Do you have that same pass still? Right. So what's our next step going to say? 6 to the negative third. And this time I am not going to skip this step because I feel like that this is one of those things that we kind of have to revisit from time to time. So 6 to the negative third equals m plus 6, right? There's a little bit of meat on this bone. I think that when we did like 8 to the second in the last problem, that was like meh, easy peasy, right? But what is 6 to the negative third? Say it again. It is not. It is 1 over 216. Very good. So as is always the case with math is, if you get behind on one concept, it will just then keep coming back and pinching you and biting you because like at this point, I assume that you're familiar or somewhat comfortable with that. The negative exponents don't turn things into negative numbers, right? They turn them into upside downies. And so that's all we had to do there. So what would you do with this equation? Yeah, I would subtract 6 from both sides. It's a little bit uncomfortable for us here, but as always, there's going to be a little bit of a basic skills bite here. So we're going to have m equals something. So the question becomes, how do you take 1 out of 216 and subtract 6 entire wholes? Right. And so you've seen this before. In fact, you've seen it in pretty recent memory that we're faced with like how do I make an integer or a whole number into a fraction that plays nice with another fraction? And Cooper nailed it. It's like just take this number uh, and multiply it by what you want the bottom of its fractional version to be. So we're going to take negative 6 times 216. And what is that? Yeah, so we're actually going to be doing the math problem 1 out of 216 minus 1,296 over 216. Good. So the answer is negative 1,295 over 216. So much of math comes back to just the basics, the stuff you learned in 4th, 5th grade. It's like it just keeps coming back, right? Common denominator, baby. So I was just going to tell you if that process made you uncomfortable, I am going to go back in a little time machine. Since this is a recorded video, I can do stuff like this because anyone can rewind and say, oh, I need to see that again. So there. Uh, if what I just did made you uncomfortable, go all the way back to when I taught you guys a class called Algebra 1. I taught you guys the fine art of fraction killing. And so if you feel like this is worth your effort to avoid having to do what we just did, you could multiply the whole equation by 216. And what that does is it gives you 1 equals 216m plus 1,296. And then from there, it feels a little bit less stressful to a lot of people. Then you can just subtract the 1296. If that last thing that I did causes you no stress, then this probably isn't the right method for you. Like just roll up your sleeves and deal with the denominators. But if you like this method better, you see you're still going to wind up with negative 1295 over 216, right? So you pick. But either way, that's what that one comes out to be. That was a little rougher. Any questions there? Okay. Now we're going to add a little bit of extra layer, a little extra meat on the bone here, so to speak. So we're going to do log base 7 of x minus 4. It's always interesting as a math teacher it's more than interesting. It's really fun to watch your guys' instincts develop. And so when I put a problem like this up on the board, having this be our first example of this type, I'm always amazed at how often you guys just instinctively know what to do. Any thoughts on the matter? Yeah. And that's you hang out with people like me and do math long enough, and you just start to develop this sense, this spidey sense that you just know in your heart that that five is not where he should be, right? So that is kind of what this portion of the lesson is about, but it shouldn't take too long because like you just know. So the five has to go. Like there is no water cycle if there are any excess parts, right? The five is like, whoa, I can't fit into this little cute water cycle thing you're talking about. So let's get rid of the five and turn it into log base 7 of x minus 4 equals 3. And then from here, more of the same. We're going to water cycle it out and solve it. So don't know that we need too many examples of that. But the moral of the story there is, of course, and you'll hear me say this a lot more in the coming minutes, is you really need to get the logarithm by itself. You remember with absolute value, that was like our battle cry. Get the absolute value by itself. Like those of you that got that memo felt more success in that chapter than others. That becomes our thing here. Get the log by itself, get the log by itself. And that'll mean even more in the next examples. But in this one, if we water cycle this up and out, we get 7 to the third, which is 343. So we have 343 equals x minus 4. So what's x? Just like that. Okay. I try in my notes to have every problem have like a little takeaway. And the takeaway there is, again, get the log by itself. Get all the extraneous or extra garbage stuff out of the way. Add if you have to, subtract, divide, do whatever you got to do. All right. I'm leaving every example in because I wrote them for a reason, and I just need to trust myself that they're all here for a reason. So this next one might feel like a repeat, but I'm sure that it's not. So we're going to do log base 11 of negative 3n minus 9 equals negative 11. And I'll just give you a heads up. I use technology a lot of times. You guys know that software that I use. It's that CUDA software. Whenever you see one of those plain Jane boring worksheets, I always make it using the same piece of software. That software does not put parentheses around multiplicative arguments like this. So much to my chagrin, and I try to go back and fix it, but if I ever just kind of on the fly create an assignment for you, this is what it'll look like. And I don't like it, but I do have to go back and manually add them, which I get the computer will only put parentheses if it's an additive argument. So like if the argument of the log is like x plus 4, the computer will do what it has to and put parentheses, but it does not put them around these multiplicative arguments, which I don't like it. I read this if I were a kid and I'd say that just looks really weird. So if you see something that looks like my handwriting on a photocopied worksheet, it's because I add those in myself. Okay. But if I, like I said, if I ever just print one on the fly for you, like, hey, could I get more practice and I just make up print, you might have to ask or add those yourself. Just FYI. All right. Step one, what do we do? Yeah. Basic algebra, right? Let's add 9 to both sides. What's negative 11 plus 9? Right. And then from here, we're going to hit it with the old water cycle. So what's that going to say? And there's a tiny bit of, you know, work left, and the rest, again, just comes back to basic skills after we get past this. What's 11 to the power of negative 2? 1 over 121. Good job, you guys. I've had years where I couldn't get people to stop saying stupid things like negative 121. And I was like, man, that was a rough period of my professional existence. So thank you for not thinking anything negative there. Good job. Equals negative 3n. And then how do we solve it? We divide by negative 3, in which really the answer is going to be pretty quick. It's going to just say n equals negative 1 over 363. So pro tip, life hack from me to you. when you have a fraction and you divide it by a whole number, you can really just multiply the whole number to the bottom. It's pretty common sensey, right? That if you make the bottom 3 times as big, you've made the fraction 3 times as small, right? So that's pretty logical there. All right, any questions on that? That's past the halfway point now, so got 4 to go. Right, we're going to add a new intruder this time, and again, you'll probably spot it just using your amazing spidey senses. Prior to yesterday's lesson, I think it was yesterday, it might have been 2 days ago. 2 days ago. Prior to Tuesday's lesson, you would have said, Mr. Ahern, I think you forgot something, but I did not. What's missing that we know is actually there? The base, right? And we know this is a common logarithm. Therefore, by definition, it has a base of 10. You're always welcome to write in the base of 10. Like I said before, I generally don't, but I would in this case just because maybe it's been a minute or so. So good. All right, so follow your spidey sense again. Which number to you just looks like it's got to take a dirt nap? Yeah, we need to divide by -4. And again, this one never goes away for me. This one I can't escape, no matter how many years. And this is honestly one of my best years of teaching. And I don't think it's because of me. I think I just got really good kids this year. But I still, even this, and probably my best year, my most successful year, I still see people adding 4. And I don't know really how to coach that out of you other than to really get you to think like the difference between a -4 and a -4 is really of paramount importance here, right? So adding 4 here, if that even crossed your mind, you're probably who I'm talking to. Don't do that, right? That's a multiplication scenario. The -4 is stuck by times. So we're going to divide both sides by -4. That's going to leave us with the log of k plus 3 equals 2. And then at this point, you can water cycle it up and out. What's it going to say? So I'm just going to say 100 equals k plus 3. And that resulted from water cycling with the invisible base 10. 10 to the 2th is, of course, 100, right? So subtract 3, what do you get? Just like that. And you probably know, because you've been in my class for a long time, that now what I'm going to do is I'm just going to kind of put it all together. So the final push here, these last few examples, is we're going to have multiple intruders, like multiple preparatory steps that we have to do before we can actually water cycle and solve. The solving process is not what we're doing in the initial steps. We're just cleaning up, we're tidying, and then the solving begins when we water cycle it and convert it from logarithmic to exponential. That's the kicker solving step there. So the rest is just cleanup work. Just never know if you're interested in this stuff. But from my experience, the most catastrophic thing that I've seen kids do is 12 plus 3. And boy, does that one almost keeps me up at night, right? That's just so offensive. Don't do that, right? Order of operations kicks in and just tells us, follow your heart. What has to go first? -12. Like that, we just know. And if you would struggle with that, just answer me this. If I gave you this exact same equation, but instead of all of this purple stuff, if I just put like a variable, you know as well as I do that it wouldn't even cross your mind to do 12 plus 3. So don't bend or break the rules of algebra just because things look different. Fundamentally, it's still, I'm trying to get that purple brick by itself. Fundamentally, I still follow the same laws, right? So anyways, yeah, if I take away 12 from both sides, I get 3 times the log is equal to 3. And then I divide both sides by 3, and I get the log is equal to 1. And this is where the solving process begins. I tell people, like, you can't really solve a logarithmic equation necessarily, but what you can do is, and that's a lie, I just say that, you can convert it to another format and solve that. So having said that, when you hit this with the water cycle, what do you get? Right. 4 to the 1th is just 4. Divide both sides by -2 and x equals, well, -2. Done. And again, you will not get any extraneous solution, so you don't have to stress over that today. You're welcome always to check your answers. Like if you wanted to go put it back in and see, like, does it all actually work out? I mean, that's okay, but you're not going to get any wrong answers because you're breaking laws at the end. Like you're not going to get negative arguments and things like that. Not today. So is this easy? Good. Who has to go first? Say, yeah, how do we tackle that? Add 4, right? So that leaves us with -2 logs. Hi, Evie. You want me to move that chair for you? You want Cooper to move that chair for you? Thanks, Super Cooper. Everybody good on that? Divide by -2. And after this, we'll be ready to hit it with the conversion. So log base 5 of m-5 equals what? That was an interesting side. I think our rhythm got thrown off. But you guys all panicked just now on 8 divided by 2, just for the record. I found that to be interesting. So is everybody okay? Are we okay? Tyson, you're good? What about Woody? How's he doing? Austin, you okay? Yeah. You sure? Okay. Okay. That's odd. What a little, you just went through like a wormhole or something. All right. What's that? A 6.5? And I'm like,
625.
so he was just hi. He's a step ahead of us. Good. Yeah. So now it's time to hit it with the water cycle. And yes, Sutter, in your defense, 5 to the 4th is in fact 625. Therefore, m has to equal 600. Hey, let's make it official and just finish the note card. I have one more on here, so let's just get this one done and then it's work time. So that is that. If I were a good singer, I would sing this to the tune of, I would sing It's the Final Problem to the tune of The Final Countdown by Europe from the 80s, but I'm not going to do that. So you're welcome just to envision it, pretend it's happening in your ears. What do we do first? Yeah. And again, weird things happen. Like we abandon our basics. Like here's what I know. Listen, here's what I think I know. If I gave you guys this equation, 10 minus something you're trying to get by itself equals 13, I have infinite faith that literally every one of you in this room would never say something as ridiculous as divide by 10. But it starts to change. Even my best students start to say weird things as soon as the thing I'm trying to get by itself doesn't just say X, then we abandon all common sense at times, it seems. So for goodness sake, that's still a 10 that is separated by a plus or a minus. It needs to be moved by subtraction or addition. In this case, subtraction, right? To be clear. So we're going to subtract 10 from both sides. However, that does not free the logarithm. We're not ready to water cycle it yet because of that pesky negative, right? So now what do we do? Now you divide by negative or -1, however you like to say that. And that leads us to the log finally by itself equal to -3. It's at this point that, if I kind of like I've done it before with like absolute value, this is where I would draw the line, so to speak, and say phase 1 is done. We're now entering phase 2. Phase 2 is where we actually begin to figure out what the answer is. At this point, we're cutting the vegetables before. Now we get to actually cook the meal, right? So what's this going to say when we cycle it up and out? Nice job. 1/1000 equals W plus 8. And again, to the rescue, bless you, is that invisible 10 base from the common log. And when you take 10 up to the power of -3, you flipsy-dooski, put the 10 to the third on the bottom. So again, if you're someone who's like deathly afraid of fractions, it's literally the reason why I teach an entire like week-long unit in Algebra 1 on fraction killing. If you just dread fractions at this point, you're like, I'm not even messing. I'm just going to multiply this whole thing by 1,000, right? Like we're going to get there no matter what. So if I do it this way, for you fraction haters, fraction chickens, we're going to get 1 equals 1,000 of those W's plus 8,000. Next step. Subtract that 8 grand or that 8K from both sides. And what is 1 minus 8,000? -7 buttload of 9s. And then we divide both sides by 1,000. And so we get W equals -79.99 divided by 4,000. And that is that. You guys think you can handle a bunch of those? All right, next week we will get into logarithm equations that are more complex. We might detour first, though. I haven't charted the course. We might take a side few days into expansions and condensing, and then come back and complete log equation. Haven't decided yet. I'll ponder it while I'm playing Elden Ring over the weekend. So how's that?